I'm going to flash this code into this microcontroller. This is an STM32 NUCLEO-F446RE. It is an Cortex M4 chip running at like up to 180 megahertz. It has two DAC pins, PA4 and PA5, that convert digital values into real analog voltage. The DAC is like 12 bits, so 496 voltage level up to 0 and like 3.3 volt. So the code does it like it runs those equations in a loop thousands of times per second, and output of two values as like voltage on like PA4 and PA5 goes to the channel 1 and PA5 goes to the channel 2 on the oscilloscope. So XY move. Okay, now we have already flashed the code inside this microcontroller. So let's start this oscilloscope. I will start from here. It started, and now the code that we have flashed, we will see it first. Here I will correct on XY mode as we discussed, and then we will see the focus. It's not, we can wait. Okay, now we can see this. Let me correct it more. So here, like, look at that. This is called Lorenz attractor. The beams goes around this side and then suddenly jumps to this side, then comes back, and you can like never predict when you like switch it. If we will like let this run for an hour, the trace will never follow the exact same path twice, but it is also never goes off to the screen, and it is always stay inside this butterfly shape. And in mathematics this is called like a strange attractor. So now think what just has happened here. Three simple equation with just fixed number, no randomness at all, and they produce this a pattern that never repeats, and that is like deterministic chaos. So this is like known as the chaos theory, and that like we have observed everything on the oscilloscope itself. So yes, you can like look at this also intensity. You can play with this. We can change the places, positions here, up and down, left to right. But let's so yes, this is what makes the instrument so powerful. It does not like show any you like a simple waveform. It can show you everything from a basic sine wave to something as complex as this. So all on the same script. So to wrap up, an oscilloscope measures the voltage over time, 3 controls to master volts per division, time base and trigger. XY mode lets you to plot two signals against each other, and today we use all of that to visualize set of equation from the 1963 that still fascinate mathematicians and engineers to this day. So thank you so much for watching.